All right, here we go. Welcome, everyone. Good to see you here at Fiveable. My name is Jerry Kossoff, and this is the AP Stats stream. Hope you're in the right place. Hope you guys are doing well tonight. Definitely say hi to each other down in the chat. Let people know how you're doing. We've had a lot of news these last few days and I guess weeks. We here at Fiveable, we're kind of reacting to some of the stuff with the College Board last week. And so this was originally going to be a stream about chi-squared tests. And with the news on Friday about the different units being tested and not tested, chi-squared tests are no longer a thing on the AP exam. So while we will have you covered with chi-squared tests another time this year, we want to make sure our evening streams are really focused on stuff that you're going to need for the AP exam if you do choose to go ahead and take it in the online format. And so we are going to spend some time tonight reviewing Z and T procedures, confidence intervals, and hypothesis tests for proportions and means. And of course, you can follow along with anything that we're doing. We've got tons of content going up, trying to be responsive to things. And we're going to start with just like a big picture overview of like when we say inference, what does that mean? Even with the new testing format, it is almost a certainty that you're going to be asked some questions that involve inference. No question about it. We're going to practice what procedure to run, whether it's a Z procedure, T procedure, one sample versus two sample, and actually do some practice naming them, looking at some recent free response questions that I think would be representative of ones that we might see in the future. And then we'll talk about specifically what you need to show to get as many points as you possibly can on those free response questions. So we'll probably do, you know, 1 or 2 or 3 of them. So let's hop in. As I'm talking about the big picture stuff, if you could put in the chat what the last live thing you did with your teacher is, whether that was through virtual learning or, you know, a week or 2 ago before we got out, what's the last thing you did in your AP stats class? So I kind of know what we're working with. So Brian's did match pairs. And if you're here coming in from last week, welcome. Good to see you guys again. We're going to be doing some like more holistic review as opposed to last week when it was specifically about t-tests. But the big goal of inference, finishing chi-squared, reviewing tests for a test on all the tests. Yes, the test on tests. That's always a thing in AP stats. Well, you're in the right place for sure. 2 proportion z-test intervals, self-teaching. Yep. Hey, Madison, good to see you again. So the general goal of inference is in some way to gather information about a population using a sample. At its core, that's what we're doing. And the statistic we get from the sample, or statistics, will provide the basis for making an estimate of an unknown population parameter or parameters. And the ones that we do the most in AP stats are proportions for categorical variables, means for quantitative variables. We also could have differences, so p hat 1, p hat 2, x bar 1, x bar 2. And the 2 big things, I'm seeing people drop these names in the chat right now, confidence intervals and hypothesis tests. So confidence intervals, we know you get a range of guesses for some unknown parameter. Hypothesis test is when you can decide to reject or not reject a null hypothesis and go with a potential alternative. And we can even use, if we're doing a 2-sided test, you could use a confidence interval to make a decision about the hypothesis test. These things can go together. But ultimately, you know, you've got to figure out what you're trying to estimate, check some conditions, and then our conditions are the same for both sets, the random, normal, large samples, and then that 10% condition. You're going to take a sample. Is it supposed to be a blank screen right now? Uh-oh. Yeah, say I'm hoping. So Katie, looks like you're seeing a blank screen. So no, I think other people are seeing things, Katie. You might need to try to refresh your page. But let us know in the chat if that's something that's happening to other people. Brian, to answer your question, I did a little more research, and I'm gonna pull some things up about that 10% condition as we get into a little bit later in the chat. But yes, 10% is a good thing to check. All right, so decision tree. In a couple minutes here, we're gonna start doing some practice. Okay, but if you're being asked to make a confidence interval, you will know that you are being asked to make a confidence interval. They're going to tell you, construct and interpret they'll give you a confidence level, some kind of interval for whatever you're trying to estimate. But a hypothesis test, they might be a little slick with it. So if you see the phrase convincing statistical evidence that whatever, that's our code for a hypothesis test. And more specifically, it's our code for an alternative hypothesis. Whatever you see after that phrase, that's our alternative. And then once you know if you're being asked to make an interval or run a test, you got to figure out which one you're doing. And there's two big things I want you to focus on. At the core, is the data you're looking at categorical or quantitative? Because if the data is categorical, you're going to be running a Z procedure, especially now that chi-squared tests are out the window. You won't have to worry about, am I doing a 2-sample Z test or is this a chi-squared test? It's going to be a Z test if they're giving you categorical data because they've restricted the AP exam to just focus on Z procedures and T procedures. If the data is quantitative, then you're probably running a T procedure. And I will make the caveat that, yes, you can run a Z test for a mean, but on a free response section of an AP exam, an inference question is not going to ask you about a scenario where we know the population standard deviation and ask us to estimate the population mean. That's not going to be a situation that we would actually run into typically in the real world or even on an AP exam. So it's going to be a T procedure. Okay, the second thing you should ask yourself is how many groups are being represented. Okay, it's kind of obvious that there's only one sample being represented. But if there's 2 samples or there's 2 groups and you're running a T procedure, you have to be careful about whether you're running a 2-sample test or a matched pairs test. And with a 2-sample test, they need to be independently selected groups that do not interact with each other for whatever the data collection is. So if there's an experiment of some kind, the 2 treatment groups need to be separate individuals. And let's say there's 100 people and they break down group A and group B and you get randomly assigned to one of those 2 groups. Then you can run a 2-sample T test if there's one big group split into 2. But if you have the 2 sets of data coming from the same individuals, you have done a matched pair scenario and you're going to run that data as a 1-sample test, but it's still a matched pairs test for a difference in means. And as we go through the next few examples, I hope that you'll be able to pick these out. So there's 1-sample Z tester interval, 2-sample Z tester interval, 1-sample T tester interval, 2-sample T tester interval, match pairs T tester interval. Those are the, I would say 10, but it's really 5 things you need to know, and then differentiate confidence interval hypothesis test. And now you've got 10 things they could ask you to do. And I am as sure as I can possibly be that one of those 10 is going to be the subject of one of the free response questions with whatever the AP rolls out. And we'll get more details about that in 10 days. The general naming template, when you are actually naming it as part of your setup, is blank sample, blank interval, or test for a difference of, if it's a 2-sample, population, whatever, proportions or means, with the exception of a match pairs test. I feel like we're good to go. You guys ready to start seeing some scenarios and picking out what tests to do? I hope so. Yes, no, maybe. I don't have a very active chat right now. Yes, sir. Yes, Katie. Love it. Let's do it. Right. And if you have, yes, I guess, if you have a TI-84, for the next few ones, I actually just want us to name the test and not necessarily run it or make the interval. But if you are like trying to do the most or do extra, feel free to hop in on your calculator and do it. I use TI-84s. But here's a scenario from a couple of years ago. The manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with soft drink from the beverage fountain. Yeah, I do that. The manager selected a random sample of 80 customers who asked for a water cup, and found that 23 of those customers actually filled the cup up with a soft drink. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. So can I make this slides? I'm trying to figure out. I'm usually really small in the window, and it looks like I'm much bigger, and I don't know if I can do that. I know sometimes for your end, if you change the proportion of your screen or like the side of your screen, am I taking up like half the room for you right now? Not room, like half the, Yeah, that's really weird for me. Usually I'm taking up a really small size. So let me like stop my video and see if this will change it, because I really do want the screen. Yeah, it's still the same. Let me try. I do apologize because this has not been a thing that has happened to me before. Typically, I see my full full slides here. I might be able to just kind of remove my video entirely. Yeah, I'm just going to remove my video entirely as we do these so that you guys can see the screen. All right. Is that a little better? You don't get my beautiful face, but you should be able to read a little bit more. No problem, y'all. Okay. All right, so let's back up. I'm now going to look for some answers in the chat. So we've been specifically told to construct and interpret a 95% confidence interval. So those of you that have been saying test as a part of your answer, we are not doing a hypothesis test. They are explicitly asking for an interval. So what kind of interval? Sorry, I'm in interval. Yeah, it's all good. All good. Yeah, this is going to be a one proportion or one sample Z interval for a population proportion. Yes, that is the big fancy name for this, one sample Z interval for population proportion. Yes, on your calculator, it's called one prop Z int. And I don't necessarily think you'll get totally dinged if you say one proportion Z interval, but you should make it clear that it's about a population at some point in your answer. All right, here's another one. This is from 2018. I won't read the whole top of it to you. The key stuff is at the bottom. Actually, no. Key stuff. A study was conducted in which 210 patients needing surgery to repair a torn ACL were randomly assigned to receive either the standard procedure or the new procedure. Summary statistics on the recovery times are shown in the table. Do the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure for patients similar to those in the study? Okay. Bonus for those of you suggesting a test, write out what your either the null or the alternative hypothesis. Don't necessarily need to do both. You mean null or alternative hypothesis. Yep, Jess, you definitely meant sample. Two proportion t-test is not a thing that would exist. All good. Curious. Nope, that takes up the whole thing. I'm just going to have to, you're going to have to live with my voice and not my face. Oh, well. Two sample t-test, two sample t-test. You guys are right. This is a two sample t-test. And we're going to say more specifically for a difference in population means. Null hypothesis difference is 0. Alternative difference is less than 0. Car owner. Those are the right, that would be the like difference equals 0 and less than 0 is going to be good. Make sure you're specific with what you're subtracting in what order, because depending on how you put it, you might end up not totally having it. Yeah, Katie asked, do you have to include difference in population means? So I have a hard time with this because the formal name for the test is a two sample t-test for a difference between means or difference between population means. The rubric gets a little kind of hairy on like naming the test. All of the like exemplar student answers will specifically say two sample t-test for difference in means. So on your calculator, if you're going to say two sample, make a habit of saying two sample for difference of blank instead of just two sample t-test or two sample z-test. I would add that difference of means, two sample t-test for difference in means or difference in proportions. Katie, to answer your slightly off-topic question, I don't have an answer at this point. I think we're going to get more details on April 3rd, unfortunately. And I'm loving these hypotheses that we're seeing. So It looks like Nuha said the difference between mean recovery time from the standard procedure and the new procedure equals 0. That is lovely. That is lovely. That would be the null hypothesis here. All right, here's one from last year. Tumbleweed, commonly found in the western United States, is the dried structure of certain plants that are blown by the wind. I'm not even going to attempt to pronounce that one. A type of plant that turns into tumbleweed at the end of the summer is a problem for farmers. And they give us all this wonderful detail and about glyphosate as a thing we're going to use as a, I guess, herbicide. But we were told in 2014, 19.7% of 61 randomly selected plants were resistant. And in 2017, 38.5% of 52 randomly selected plants were resistant. Do the data provide convincing statistical evidence at the level of 0.05 that there has been an increase? To sample. Katie said X test. Katie, I'm guessing you meant to type a Z instead of an X there. To sample proportion Z test. Max, I would clean up yours by saying to sample Z test for proportions or for difference of proportions. Because to sample proportion kind of back to back makes it sound like you're doing a test for sample proportions and not for a population proportion. To proportion Z test for difference in proportions. Madison, that should work. It is to sample proportions because it's percents. Yes. This one actually tripped people up a little bit last year because they didn't give us the number of yeses in each group. They gave us the p-hat in each group. So the p-hat for 2014 is already 0.197, and the p-hat in 2017 is 0.385. But if you're given a percent, it is a proportion. This is a to sample Z test for difference in population proportions. I got two more for us. This one was from way back in the day, 2006. I don't even want to ask what y'all were doing in 2006. But we are given data about a random sample of 150 patients with heart attack symptoms who had reported to the emergency room. For each patient, the mode of transportation and wait time were recorded. Summary stats for each mode of transportation are shown below. If you were in my stream last week, I used a problem real similar to this one. But this says to use a 99% confidence interval to estimate the difference between mean wait times for ambulance transported patients and self-transported patients at this emergency room. Okay, I see two sample. All right, I'm loving the two sample T that I'm seeing. Two sample T, two sample T, two sample T, two sample T. Two sample T interval, though, is the specific. Yep, they specifically asked for a confidence interval. So this would be a two sample T interval for a difference in population means. Difference in population means. Difference in means will also be okay. So what Madison wrote, if you place two sample T test with the word interval, difference in means will be okay. You strengthen your answer by saying the word population to make it clear that it's about the parameter and not the statistic, but it is not required to get full credit to say population. All right, uno más. This is an AP famous problem from 2014. I'm going to go through it, the whole thing. A researcher conducted a study to investigate whether local car dealers tend to charge women more than men for the same car model. Using information from the county tax collector's records, the researcher randomly selected one man and one woman from among everyone who had purchased the same model of an identically equipped car from the same dealer. The process was repeated for a total of 8 randomly selected car models. The purchase prices and the differences, woman minus man, are shown in the table below. Summary statistics are also shown. Yeah, Austin, tons of filler data. And not only was it like that, they also had dot plots. I ran out of space on the slide. I was like, let me not do this. But the question was, do the data provide convincing statistical evidence that on average, women pay more for men in the county for the same car model? Oh man, everyone's saying match pairs. I really thought I could fool y'all on this. Can someone put in the chat why this is match pairs and not a two sample? Yep. But it's men versus women. Those are two separate groups. Ah, okay. So the data is being collected on the same car, even though there's two different people assigned to each car. Yep, this is a match pairs test for difference in population mean. Austin, be careful about what you wrote, 2 sample match pairs t-test. That is not a thing. This was a single sample. The sample was 8 randomly selected cars. And then they found 1 man and 1 woman per car. Yep, same model of identically equipped car. Katie, that's a good thing to pull out from that problem. Yeah, okay. Good luck, y'all. Good luck, y'all. This is a match pairs t-test for a difference in population means. Okay, so at this point, okay, we've gone through some recent examples of actual AP problems. I'm gonna put my video back up for a little bit. How would I solve that specific problem? Yeah, that's a good point. I'm gonna come back on video here in a second. Close video. I should be on video. Oh, you guys just lost my screen though. Okay, so that specific problem we can come back to a little later. But Katie, to answer the 30-second version is I'm going to run a t-test, not a 2-sample t-test, but a t-test with the difference data. So they give me the data on mean and standard deviation for the difference of 585 and 530. I would put that into a single sample t-test and compare it to mu equals 0. So the difference would still be 0, but I'm putting in the sample data difference, 585 for X bar and 530 for S. And then my N is 8 because there were 8 cars. All right, so I'm back. Scale of 1 to 5, how we feeling about picking out what test to do and how to name it, or what procedure to do? Brian's at a pi. Oh, 3.0. Oh no, someone's at a 0. 3, 4. Okay, yeah, we're feeling pretty solid. That's good. So once you identify what you're doing, okay, I mean, getting the data into the calculator is really easy once you know which calculator test you're going to. And the AP readers know that. So they're going to make you try to show a lot of stuff on the free response. That's not just the p-value or not just the confidence interval or not just the t-test statistic or whatever it is. Okay, so if it's a confidence interval, you have to start. I mean, Brian, to be honest, that can work sometimes. If you know you have to put in a mean and standard deviation and you are looking at a menu that talks about X and N as like proportions, you're in the wrong place. Or if you're trying to do a proportion, a z-test, and you find yourself looking at a menu that talks about mean and deviation, you're in the wrong place. I mean, it's not foolproof, but yeah, you can kind of click around a little bit. Ultimately, we are going to be using, okay, on these menus, 8 is a t-test, 1 sample t-test. 0 is a 2-sample t-test. A and B are your intervals. 8 and 0 are intervals. A and B are intervals. And then 2 and 4 are your t-tests, and 5 and 6 are your z-tests for proportions. You're never going to use the regular z-test, regular z-interval, or 2-samp z-test or 2-samp z-interval. So of the 10 things you need to be able to run, these 8 buttons are the buttons that you need. So once you've identified what test it is, go to that button, you can put the data in. In terms of what you need to show for confidence interval, okay, I've got to check my conditions and name the interval. We just practiced naming the interval. Put in the chat, what are the conditions for a confidence interval? What do you have to show? Just in general. Independence, random. Okay, there's one more. So there's the random condition. Okay, yep, the random condition and that normality, or someone said big enough. Okay, so you got to cite something about, yep, that normal or large sample condition. Okay, I like to call it RN10, random, normal, 10%. Those are the 3 things we got to show. Okay, Z intervals, I saw someone show it. Successes and failures got to be at least 10 in your sample. That's a big enough sample for proportions. For means, you have to have a sample size of at least 30. No, that is the wrong thing to close, y'all. I wanted to share this, and I want to reduce my video so you guys can see it. Ah, this one I can close. There we go. Okay, this independence condition. We have to assume that because we're sampling without replacement, that we have a big enough population that our sample is small enough within that population that we're not changing the underlying probabilities. This is a condition to check for Z intervals and Z tests. I have not seen this on any rubric for T intervals or T tests. This has been a thing on Z intervals or Z tests, this 10% condition. In 2017, the problem I showed you with the water cup, the rubric for that year mentioned that it was nice to check this, but not required. But the 2019 rubric with the tumbleweed did explicitly check for this. So if you find yourself doing a Z interval, I would explicitly check this 10% condition. Will confidence levels other than 90 or 95% be very common? No, the most common is 95%. The next common, most common is probably 99, and then 90 shows up. Sometimes if they're doing an investigative task, like that question 6, they'll throw in a 96 or a 98%. But you'll have a formula sheet, and especially with the shortened test this year, I can't imagine that that'll be a thing they prioritize. Okay, and then we interval name. These 4 things are typically all wrapped up, or if it's a T interval or a T test, the 3 things, random, normal, and the interval, those are wrapped up in one like part of the question. Okay, then you go to your calculator and actually get the interval. That's going to count as a second thing. If you're running a T interval, you should list your degrees of freedom. Anytime you're doing a T procedure, you got to show the degrees of freedom. And then you interpret the interval with something like this. Someone was mentioning before, make sure you put the context of the problem, write out your sentence in the interpretation. You literally can just copy and paste what the problem says a lot of the time. So with with the soda cup, the water cup problem, you would say we are 95% confident that the true proportion of all customers who would fill up their cup with soda when they ask for water is between whatever your lower and upper boundaries are. If it's means, you should list the units there. Yep, true. True is there to show that you're making some kind of conclusion about the entire population or entire parameter. Comments, questions, concerns. Feeling this in the chat. I want us to do you have to include true? You can replace the word true with population. Do you have to say what you wrote in the calculator? As in like what you typed into the calculator, like x equals blank, n equals blank, or x bar equals blank, s equals blank. If you've named the interval that you're building, you do not need to show what you put into the calculator. They will know where that came from. I'm going to look to see if I can see a student sample from 2017 real quick. Here we go. Okay, this is, where'd it go? Yep, so I'm going to switch screens for a second so you can see a previous student. Where is it? Close that video. I'm going to share a different tab. This was 2017. Okay, this particular student got all the points, and you'll notice they named the interval at the top. They mentioned the randomness. They showed that 800 is probably less than the size of the entire population. They checked the greater than 10, and then step 3, they literally just wrote the answer from the calculator, and they're getting all E's on this part. So you can always do that. Yeah, I use technology to reach this conclusion is enough. As you can see, can I link the student sample? I sure can. I am good at technology. I can do this. I have too many tabs open though. Where is it? Ah, this is the one. I'm going to put this in the chat right now. This is all publicly available, which is why I can do this. Here at 5 Bull, we're all about using resources that are available to you. All right, so I'm going to go back to our main presentation now. Switch this video, share screen, Chrome tab. Cool. So that's what hypothesis test or confidence intervals should look like. Okay, hypothesis tests. Good news, they're super duper duper similar, but just start with your hypotheses. Okay, remember null hypothesis should always have an equals. Alternative should always have a less than, greater than, or not equal to. This is also a great place to define your parameters. The independence condition. Yeah, let's do that again in a second. Draw a picture. Pictures are nice. Okay, the independence condition for Z intervals or Z tests has to do with, goes back to binomial distributions. When we're sampling without replacement, the scenario is no longer independent. So like if I'm looking for someone to, like, what proportion of people are going to fill their cups up with soda instead of water, the idea is, like, in the population, there is a certain percentage of people that do that. And if the first person I see does that, I have to figure out, is the next person now more or less likely to do that now that I've seen the first person do it, or are they just as likely as the first person to do that? And if you have a pretty small population and you're taking a lot of people out of that population, every person you see will change the probability of the next person doing that thing. And so if the population is really, 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 really big, though, the denominator of every person, the chance of each person doing that thing, will not be changing when I sample without replacement by very much. And so even if the probability changes, it'll change very, very little. And we can assume that, like, whether or not the first person fills up their cup won't have anything to do with whether or not the second person does. Drawing a picture for independence, you do not need to draw a picture for independence. Brian, are you referring to, like, what kind of picture are you referring to? I'm not quite sure what you're discussing there. But Madison, you could test a normal curve. Yeah, it can be helpful to sketch a picture. You do not need to sketch a picture. But having the null and alternative hypothesis there can be useful for sure. Madison, a place for you to go back and review would be looking at binomial random variables and discussing independence of those. And the conditions are going to be really similar for that. All right. Absolutely. Absolutely. Type 1, type 2 errors. Katie, good question. I did not include that on this stream initially, but we can talk about that. Yeah, power is the thing as well. So I was going to make sure we were going to have other streams coming up about, oh, those suck. Hey, I don't hate those too much, but we can do a little bit. We can do a little bit of talking about those. So why don't we go back to one of the hypothesis tests? Let's do the match pairs test. Let's do that one together. Because we were asked if the data provide convincing statistical evidence that on average, women pay more for men in the county for the same Cram model. We identified that it's a match pairs t-test. So our null hypothesis is that the average for men, women pay more than men. So we're going to go mu women minus mu men equals 0, with an alternative of the mu for women minus the mu for men is not equal to 0. Right, so those are our hypotheses. Okay. Oh, yeah, it very much should. Thank you for catching that, Brian. Greater than 0. Point for you. Deduct 1 for me. I was, if there was a convincing, if they asked for a difference, do you pay a different price? Then I would have put the not equal to sign. And what would be the parameter? Yep, the parameter is mean amount spent on the car by women versus mean amount spent on the car by men. PR parameter. So like you could write mu women and mu men as long as you identify that you're defining the amount spent on the car. Or you could say the mean difference equals 0 is the null hypothesis, where mu difference is mu is the Greek. It's the Greek letter mu, which is often used. It's this thing. It is that guy in the top right of that table. That is a Greek letter mu, and I don't have a button for it on my keyboard when I'm typing it into the chat. So that is that. No problem. Okay, so back to that problem. Okay, this is the null and alternative hypothesis, where you state the mean difference is difference in price or in mean purchase price for men and women. Okay, and I'm gonna come back on the screen now so we can talk about how to do this one. I want to add my video here. Okay, so we're gonna turn this back on. Okay, because when you do a match pairs test, where I'm gonna go on here, I'm gonna go to stat, over to test, and it's not a 2-sample test, it's a match pairs test. So I'm gonna do a t-test. And in this case, if I really wanted to, I do have the raw data and I could put it into list 1 or list 2 or list 3, whatever else, but nah, let me not do that. I'm gonna put in the stats. Anytime you're running a matched pairs test, your null hypothesis is 0 because you want there to be no difference, okay? And the X bar and the S are gonna come from the data where it says difference in mean and standard deviation of the purchase price. So in here, I'm gonna put, I think it's $585 for the X bar, and it is, ooh, it's super small now, 530.71 for the S. And my alternative hypothesis is that this is greater than 0. I love drawing the test on my calculator. Oops, the domain error. That means I put something in wrong. Come on, you blew it. Really? Oh, that means I have something. No, something's up. T-test. Anybody else trying this t-test on their calculator right now? I should be good. X bar is 585. Oh, I didn't put my sample size. Ha ha ha. Sample size is 8. I tried to do the test with a sample size of 0. Can't do that. If you draw this, it's going to now draw the lovely picture. Thank you, Noah. You caught me. Okay, and I see I've got my t-test statistic. Boy, women pay a lot more than men, which is a larger societal statement, I think. But ultimately, that p-value, 0.0084. Okay, so what am I going to do? What am I going to write? Let's do our conclusion. Let's do our conclusion. What would I say about this p-value? You can drop something in the chat here. What would it tell me about this scenario? Yeah, and Kristen, specifically here, they asked if women pay more on average than men. Alternative is true. Katie, can you say more? And I'm going to come back to what you need to show to respond to questions. Okay, yep, that's why we're here. All right, so I'm going to close my video again for a second. Okay. To get credit for interpreting the p-value, we need to do 3 things. You need to explicitly compare your p-value to a significance level. The p-value was 0.008, by the way, 0.008. That's what we got. Okay, we have sufficient evidence to reject the null hypothesis in favor of HA. All right, Kristen, you have done one of the 3 things we need to do. Brian, you have done all 3 of the things. Brian compared the p-value to the 0.05, named whether or not we're rejecting the null hypothesis, and then gave the evidence for the alternative in context. Kristen, if you had put the alternative in context of saying women pay more than men, then you've got it. Looks good, but I think you've got the wrong, I think you put the wrong symbol on your inequality. That is, that 0.008 is less than 0.05, not greater than. We are rejecting the null hypothesis. Yep, there you go. So that would be 2 of the 3 things. You would get a P, partial credit for that. We now need to state that we have convincing evidence for whatever they asked us, which in our case was, do women pay more on average in the county for the same car model. So women pay more than men for the car model. Okay, so we've got our hypotheses. Yeah, Riley added that strong evidence. So Riley, I'm guessing your teacher says if the p-value is less than 0.01, you can say it's strong evidence. And if it's like between 0.01 and 0.05, you can say like pretty strong, all that stuff. AP readers don't really care about strong or not strong. They just care about, is it less than 0.05? And you can say, yes, we have evidence, or no, we don't have evidence. So that's what we need to show. In this case, in practice checking the conditions, but they do mention it's 8 randomly selected car models. So for a match pairs test, you have to show that whatever the pairs are, yeah, phantoms. Hunter, can you spell those out? Madison, will it always be 0.05? It is almost always 0.05, especially if it's not specified it's going to be 0.05. You can always use 0.05 as a default. And if they want it to be something else, they will explicitly tell you. So this 2014 problem didn't explicitly state it. What are the conditions for a match pairs test? All right, this is a good question. So I'm going to spend a second here. So conditions for a match pairs test, you still have to have your randomness. You still have to have your large samples or normality, and you have to have, that's really it. The 10% condition is for z-test. So it's random and normal. Okay, with a match pairs test, you have to have random assignment or random selection, depending on if you're doing an experiment or observational study. And in this case, okay, we have really small samples. So some of you might be thinking, well, wait a second, what the heck do we do? Well, I'm going to pull up the actual AP problem that there was, and I'm going to switch which screen is which. So I'm going to close this video. Brian says draw stuff. Well, the good news was on this particular year, as you can see, they gave us dot plots. So they gave you dot plots of the tables they gave you and the differences. Okay, and so if you look, to recommend, if you look at these dot plots, do they look like they're going to violate the assumption that the differences come from a normal population? And if I look at these dot plots and they don't look like they violate normality, even though the sample's only 8 cars, I can say we're good. Yeah, they've given us dot plots. Now, the good news is dot plots are like histograms. They're just individual. So if you made a histogram out of this, you'd have 2 bars less than 0. You'd have 1 between 0 and 500. You'd have 3 between 500 and 1,000. You'd have 2 above 1,000. That histogram of only 8 individuals would not look super skewed and not have any crazy outliers. So it'd be the same as these particular dot plots in terms of we didn't violate normality. Okay, and I can pull up a student sample just like I did on some of the other ones. And whoop, boy, there's a lot going on here. Okay, so I'm going to share a screen and I'll drop it in the chat as well. Here is a link to the first one that you pull up on there is going to be a student exemplar. And let me share the screen to that one. It's going to be AP 14. So I'm going to close this video. We are going to share this one. Which one? It's the real question. I think it's this one. Yep, that's the one. Okay, the writing is kind of small. It's hard to see. Where am I finding all these? Yeah, good to see you, Riley. I'm going to stick around just for people who are here for about another 10 minutes or so we can go through these. Katie, these are actually on the AP's, there's something called AP Central, and you can view past exam questions for free. This is, you do not need to have like a teacher account or anything. Now, I can't share any of like the practice tests, but these are real free response questions. So if you Google search like 2015 AP free response, you're going to see the AP free response from 2015 and rubrics that go with it. If you dig into the AP Central website, you'll see student samples, and they always show a student sample that got full credit, a student sample that got some credit, and a student sample that missed credit. So there'll be 3 on there. So don't assume that just because they published it, it means it's right. the first one is the one that gets the credit. So you'll notice this person does a lot on their page, but they've got the hypotheses and they name the differences. Okay, they go through the conditions, random, normal. They do talk about independent, where they do 10%, like 10 times 8 is 80 cars. It's reasonable to assume that they sell more than 80 cars. But the good news is that you did not need to show that independent one. Okay, they've put all the data on their, like they didn't even do it in the calculator, they did it by hand. But that test statistic and p-value is what we got from our calculator. And since our p-value is smaller than our significance level, we reject the null hypothesis. There is sufficient evidence to conclude that on average, women pay more than men. So, you know, they give you a full page or two for a reason. There's a lot of stuff to show, and definitely a lot to do with that. Great. So at this point, I feel pretty good about going into just kind of open Q&A when it comes to hypothesis tests or confidence intervals of like what we need to show, what we need to do. I'll stick around for about 10 more minutes. So if you're still here with us live and you have some more questions, that's cool. For full credit, do you have to include the alpha? Katie, yes. You should explicitly name what your p-value is less than or greater than. So they call it on the rubric, they call it linkage. You have to make linkage of your p-value to the significance level. So you need to say something like 0.008 is less than 0.05 or whatever the situation is. Sorry, I gotta adjust my seat here. For degrees of freedom, can we do n-1 or do we need to find the true amount of degrees of freedom? If you're doing a 2-sample test, your calculator will give you the calculated degrees of freedom. If you're doing a 1-sample test or a matched pairs test, the degrees of freedom is n-1, so you don't have to worry about it. Okay, I see some questions coming in here. All right. Regarding the 2 dates, do you know approximately when the dates will be? Katie, we do not have that information yet, unfortunately. Hopefully we get more on April 3rd. How would you do a test for a difference in 3 means or 3 things? Car owner virus, that is a good question, and it is beyond the scope of the AP exam. So if you have 3 categories or 3 proportions, you might start working with chi-squared tests. For the difference in 3 means, you're going to do more advanced things in collegiate stats classes that are beyond AP. There's something called an ANOVA process or analysis of variance that has to do with, I don't know if it's 3 means, but I know I remember doing that. There's like F tests. There's some other stuff that's kind of beyond AP stats. And to be honest, I'm not 100%. All right. Type 2 and type 1 and type 2 errors also connecting to alpha levels. It's a good question. I realize we should make an upcoming stream just about the power of a test and types of errors, because this was good practice on actually running the tests. Type 1 error is the probability of a type 1 error is the alpha level of your significance level. Like that is the probability that you make a mistake. So if you set your alpha level at 0.05, the probability that you make a type 1 error is 0.05. The probability of a type 2 error has to do with power. Yeah, Madison, when you're saying how do you calculate matched pairs, do you mean like where do you get the data from, or how do you calculate the t-test statistic for matched pairs? Do we have to draw out the normal curve for the FRQs? If it is not a question about normal probability, the test statistic itself, yeah. So the test statistic for matched pairs, the statistic is, I'm going to say mu1 minus mu2. So mu1 minus mu2. Okay, the parameter is always going to be 0. And then you're going to divide by that standard error. Boy, what is the standard error for our matched pairs test? I believe you're just going to end up using, that's a good question. I'm going to put generically for right now standard error, but I believe the standard error, for a matched pairs test, Madison, I'm going to have to get back to you. I believe you just use where the sample standard deviation is for the difference and divide by the square root of n, because there's not an n1 and n2. Yeah, that's right. That's right. So in the case of the cars, our difference in means was 585. That will be -0 because we always want the parameter to be no difference. And the denominator would have been that 530.17 divided by the square root of 8. So that's the t-test statistic. That's going to be the one that results in that 3.11 that led to the p-value of 0.00 whatever. Okay. If you increase n, does the probability of a type 1 error go down? If you increase the sample size, does the probability of a type 1 error go down? I'm not 100% sure, to be honest. I'll have to, when I'm prepping the stream for type 1 and type 2 errors, I'll make sure I look at the different scenarios. I know the type 1 error is the alpha. Katie, I sure hope so. Usually the exam booklets come with the formula sheets. So I have to imagine that whenever they create the test, yeah. I don't think increasing your sample size will do anything to change your probability of a type 1 error, because you're still, the type 1 error has to do with incorrect, like doing too much, when you reject a null hypothesis when you really shouldn't have. And your probability of doing that, I don't think is going to change unless you change your significance level. So when we do power and type 1 and type 2 errors, oh no, laptop went stupid. Austin, what'd you miss? The real question is, where'd you leave off? And then I might be able to catch up a little bit. So Katie, I believe the answer is going to be yes. You will have your formula sheet for the AP exam. Yeah. Oh, seriously. What would we do without these? And if you guys haven't seen yet, the formula sheet looks a little bit different this year. They've simplified some of the first parts, and the inference is all kind of organized by section. And there's a lot of stuff. We're not going to need this bottom with slopes. We're only going to need these. Wouldn't standard deviation decrease if n increases, though? Standard error decreases, Hunter. Yes, standard error, which is the distinction of like how far off we need to be. So this is good conversation we're having. I think we can save some of the discussion about how to change the probability of type 1 and type 2 errors for the specific stream on that. I'm with car owner right now. I'm 90% sure, and I recognize you're like, hey, you're the stats teacher. Like, you should know this stuff. We got to review stuff each year too. And so I have not really been thinking about how to change type 1 error. I believe that is purely set by the significance level, and there shouldn't be anything else there. All right, Katie, and last couple of questions here. So the Cram pass and these videos. So these videos are going to be like, we're still going to do these. The review streams, they're free. They're good to go. People with a Cram pass are going to get essentially like extra study help. Car owner virus. Oh, that's really funny. I did not pick that up. Yeah. Total facepalm moment. Sorry, Katie. So to answer your question, the Cram pass is going to come with additional problem sets, additional feedback. So you're essentially, if you're buying a Cram pass, you are buying access to, for stats is going to be me. You're buying access to me to provide you with some extra streams of review content, to provide you with study guides, and to provide you with feedback on those study guides. So it's kind of like purchasing a, it's kind of like purchasing I don't want to say tutor, but it's like we're going to be a little group together and do some extra streams and stuff just as a group, and you'll have access to more exclusive content and kind of first dibs on feedback as we go through stuff, and we'll do night before streams and all that kind of stuff to get us ready. Yeah, so if you're thinking about joining and you felt that I was knowledgeable and relatable and gave you some good info, definitely consider buying one of those Cram passes. I will still be in some of the free streams as well. So if you're like, I'm not trying to shell out that money for that thing, no sweat, you'll still see me, but you will see me a lot more often if you do end up purchasing that Cram pass. So thank you guys so much for coming out. Yeah, I hope you guys do tune in. Where is the Cram Pass page? You know, if I was a really good company man, I would have the link ready to drop into the chat right now, and I do not. So I'm hoping someone else can save me. But if you're signed up for to get some kind of emails from Fiveable, I'm actually willing to bet if you go to Fiveable right now, there will be some kind of link at the top of the page. So I'm just going to go ahead and put the Fiveable link down there, and you'll probably see it. Oh, Jess got me. Yes, Jess. Thank you, Jess. So with that, y'all, thanks for the time. And I hopefully will see you guys. Some of you I'll see in the Cram sessions, and others I will see just in the free streams out here. All right, y'all. Have a good night. Take care.